Welcome to this video. In this video, we will be collecting data from the internet. Now, in contrast to the previous videos where we process data in JSON and XML format, in this video, we will be processing data in HTML format. There is still data coming from websites, web pages that are geared towards human consumption rather than machine consumption. In this case, it's a process of reverse engineering the HTML file, the HTML code, in order to get the data that we are interested at. Let's take a look at this example. This link is a link to a web page from the Congress website, providing information about the members of the Congress. Now, this particular website provides us ways to kind of narrow down our selection. So in this case, I'm interested in Congress 116. I'm interested in the Senate, but I can do kind of further filtering. I can look at the House. I can look at, members from different parties. Let's say we're interested in the Senate, since we've done the House before, and we're interested in Congress 116. Now, this is a web page, and although this information, if you search around, will be available in XML, assuming that this is only available in HTML, we need to process this HTML source code of this web page in order to get the member information. Now, any website, any web page on the internet is coded in a language called HTML. All browsers provide ways for us to look at the underlying HTML. So in the Edge browser, if I go to Developer Tools, it's going to show me the source code, the source HTML file of this page. Very much like XML, HTML file is organized in a hierarchy of tags. Now, these tags have interpretation from presentation perspective. So we see that the page has a head and a body, and in this body there are different divisions, and in each division there are probably other tags containing the information that we are looking for. So this exercise is asking us to extract the names, parties, and states of all of the US Senate members, and then answer the question, what are the states that have both Republican and Democrat senators. Again, this is a process of reverse engineering. We can take a look at the HTML file and try to understand how it's structured, or we can use some of those tools to enable us to kind of see how the code is structured. I selected the select element tool, and this allows us, if I select a certain element on the page, to see the HTML file that the HTML code corresponding to this segment. Now, in this case, you can see that we are in a division called search row. Underneath it, we are in another division. Underneath it, we are another division. It's kind of a list, basic search results, and each element, li, is basically a result of the list, representing member information. So let's go back to our code and start by doing the basics. We are going to use Beautiful Soup in addition to the request package. So first, I'm going to get the HTML page. So I'm going to issue a GET request, and I'm going to copy and paste this URL. Let's check the status code. And also the headers. What's important here is to note that the content type is text HTML. So basically the HTML text is provided here in the text attribute of the response. The next step is to parse this text using the Beautiful Soup parser. So what I'm going to do, I'm going to call in the Beautiful Soup constructor here, passing HTML. I'm going to tell it that I want to parse this file as HTML. Once I do so, I can use a function called findAll, which is very similar to the findAll function in elementary, to find all tags that satisfy certain criteria. Unfortunately, and in contrast to XML, there is nothing like XPath that allows us to specify the hierarchy, because the data itself, the HTML file, is created towards presentation. Like I want a table, I want certain bullet items, bullet points in the table. So the process of finding is basically a process of reverse engineering what we see here. Let's take a look at one member here. You can see that this member information is contained in a tag called li. That's an itemized list, an item in a list. This tag has a certain class called expanded and a certain style, which is display and block. So what I can do, I can go to Beautiful Soup and tell it to look for li tags. So let's go ahead and do soup find all li. That basically will give me all of the li tags, including the tags associated with members as well as the tags associated with something else. So this is such a broad search criteria. I'm going to narrow down a bit. I'm going to tell it, look, I want the li, but I want the class to be expanded. Again, there is no guarantee that the class expanded only is associated with members, but it seems to be so in the case of this HTML file. It seems that they're using this class to style the result page, and they call the class expanded. So I'm going to tell Beautiful Soup to look for an attribute called class, and the value should be expanded. Now, only for this attribute, because it's a reserved keyword in Python, I need to add an underscore. That's basically giving me all of the tags that have the class attribute to be expanded, and those tags, as we can see here, corresponds to members information. So if I look at the first one, this is basically what I have here, the tag corresponding to the first member in the web page. Next, we want to look at the names, state, and party of the member. So let's look at the structure of this tag. That's the beginning of the tag, li class expanded, and that's the end of the tag. Next, we have a division, and then we have a span for a member. And here we have another span with a class called result heading. Here we have Senator Alexander Lamar, for instance. So it looks like the name of the senator is included as the text of the tag result heading, the tag span in the result heading within the tag li that we captured. Similarly, if you look through, let's see where we have information about the party here. It's actually the span party underneath the span result item. This is even worse because this span doesn't have any attribute associated with it. So we should only rely on its sequencing within the different tags to be able to get it. Again, as I said, it's a process of reverse engineering the file. So there is an element of trial and error kind of incorporated here. What I'm going to do, I'm going to store this results, the first tag, in a variable called m1. And what I am going to do, I'm going to experiment with m1 and then isolate all of the steps that I have done to m1 in a function, and then call this function on all of the remaining elements in my in all of the tags. Okay. So let's take a look at m1 again. Let's say we want to extract the name of the senator. The name is basically included in a tag called span that has the class result heading. So what I can do find span. That will give me all of the spans in m1, not in the HTML file, just in m1. So this is a span that doesn't have a class. I want to do the class is result. Was it result or results heading? Let's take a look. Result heading. So that's the span, and I am interested in the text of this span. And the text is the senator name. So that's basically the name. And next, I want to get the party and the state. Let's take a look at what we have here. It seems that the party is within a span called result item, in another span within the span result item. So if I do find a span and the class is result item, that basically will give me all of the spans that have result items in it. So what I am going to do, I'm going to find all, there are multiple of them, in order to find all of these spans that have result items. Let's take a look at what's going on. So again, it's a span called result item. Okay, it's result item rather than result items. Result item. And here we get all of the spans that we're looking for. Now, within this, we can either assume that it has the same structure for all of them. So we're going to look for the first span, which is the state. And then the second span. So there are a couple of result items. The first one is the state, and the second one is the party. So what we're going to do, we're going to go to the first one. That's basically your state. And we need to find again span. And then we need to get the text. So that's going to be the state. And then the party is going to be the same, except that this party will be 1. Alright, so we managed to do this for M1, but we need to do this for all of the members. So what I'm going to do, I'm going to create a function called parse member. We'll take a member tag, and it's going to do the process here. It's going to get the name, it's going to get the state, and it's going to get the party. And at the end, I'm going to return a dictionary, name to be name, state to be state, and party will be associated with the value of party. Let's set the function here, parse member M1. So let's try this again on another member here. It's important to test the function. So I'm going to do soup.findAll. Let's call those folks members. So M1 will be member 0, and we don't need these cells anymore. Member 0. If I do member 1, I should get the next member, which is not the case. The reason it's not the case is that I copy pasted the code within the function and I forgot to change M1 to match the parameter name, which is member. So again, it's important to test our code. These mistakes happen often, and without testing they will go unnoticed. Now we do that and we get the second senator in the list. Alright, so next I'm going to process all of the list. And I'm going to use a list comprehension. I'm going to parse each member for member in members. And I get a list of dictionaries, a list of records. So the next step is to answer the question, which is reporting the states that have both Republican and Democrat senators. I can answer this question looking by processing the list, or I can construct a pandas data frame and use pandas to answer the question. Let's create a data frame from this list of records. That's the data frame we have here. Now I'm looking for states that have senators from both parties. One way to answer this question is to group the data by the party and the state, and then count how many senators from those parties and states exist. Then we can look at states that have a count which is non-zero for both Republican and Democrat. What I'm going to do, I'm going to group by party and state. And I'm going to look at name here. I just need a series, I don't need a data frame, and I'm going to count. That's step number one. Step number two, I'm going to basically unstack this data frame. I'm going to unstack it, the series to be a data frame. And I'm going to unstack it on the other axis. Oops. Unstack 1, unstack 0. Okay. The next step is to now replace all of the nulls with a 0, because it means it doesn't exist, the count is 0. So I'm going to fill NA to be 0. Let's call this one data for now. Okay, so now the criteria is that the state has to have both Democrat and Republican senators. One way to do it is to look at this number and make sure they're not zeros. So one can do something like this. Democratic is not equal to 0. That's a mask. And we can combine this mask with another mask, which is Republican in this case, is not equal to 0. That's the combined mask, and we can use the combined mask to filter out the data. Right, those are the states. Obviously, if I am interested in the state names, then I need the index of that result. Let me convert it to a list if that's what I'm interested in. So this concludes this exercise. The main goal of this exercise was to process the HTML file. Parsing data, scraping data from an HTML file is a much more kind of time-consuming process. There is an element of trial and error and reverse engineering in order to understand how the data is structured to be able to extract it from the file.